So we're going to talk about logarithmic functions for the rest of the unit. The first half of the unit was exponential functions. The second half of the unit is logarithmic functions, and it all goes together because logarithmic functions and exponential functions are inverses of each other. All right, so a lot of things we're going to do today are going to set up using logarithmic functions using exponential functions. We've already worked through all that. So some things to keep in mind. We would read this as y equals log base 2 of 32. So we have a base. We also have a base when we're talking about exponential functions. Your exponent in an exponential function is going to be what your log equals in a logarithmic function. All right. Learning target 7 and 8 today. Then 7, all we're doing is practicing rewriting them. We're going to change them from one form to the other and back. All right. So we're not solving anything. We're not evaluating anything. We're just going to rewrite them. Then in learning target 8, we're going to evaluate them using some of the ideas we did in learning target 3. Okay? Any questions, make sure you stop me as we go. So, for the first 4 examples, the first 2, we're changing the logs into exponential functions. And for the second 2, we're changing the exponential functions into logs. This is very easy if you can remember to make a circle. Always start at the base and make a circle. So, we start at the base. And you circle around to what it's equal to. So you have 9 to the 3/2 power. Remember, it always equals the exponent. And you circle back around. So you had an equal sign in between there. So it equals 27. There's nothing to solve or nothing to do. We're just rewriting it. That's a true statement. If you wanted to check, again, this is not part of the problem. If you wanted to check, how do I rewrite 9 to the 3/2 power? So the square root of 9 is 3, right? And 3 to the 3rd power is 27. So there's nothing to do here. We're just rewriting them. So on the second one, again, we would start at the base and circle around. So we have 1/25 to the negative 1/2 power equals 5. Again, there's nothing to do. That is the answer. That's what I'm looking for. But if you wanted to check to make sure that was right, 1/25 to the negative 1/2 is the same thing as 25 to the 1/2. And 25 to the 1/2 is the square root of 25, which is 5. So they are true statements, so we're rewriting. Any questions on the first 2 examples? Changing logs into exponentials. Then the bottom ones, we're doing the exact same thing. We're doing the opposite direction. We're going from exponential to log form. So we start with the base. I'll go ahead and always start with the base and circle around. So we have log base 7 of y equals negative 6. This one has a y in it, but we're just rewriting it. We're not trying to solve anything, so don't worry about it. And then the last one, you start at the base and you circle around. So log base 8 of 1/4 equals negative 2/3. That's learning target 7. Any questions about how to rewrite any of those? That's all you're doing, is just rewriting, just to practice. We're good with those. Then in learning target 8, we're going to use that idea to evaluate the logs. I want you to understand how they relate to exponentials. All right? So what we're going to do is we're going to set every single one of these equal to x. And we're going to rewrite them all as exponential functions and use the ideas from learning target 3 to figure them out. So if I was going to rewrite this first one, I would start at 2. I have 2 to the x power equals 1/16. And using the ideas from learning target 3, I can rewrite 1/16 as 2 to some power. So 16 is 2 to the what power? 4th. And so if it's 1/16, that means it's 2 to the negative 4th. So if we use the ideas from learning target 3, I know that x equals Negative 4, because the bases are the same. So all that means is that log base 2 of 1/16 is negative 4. So we're going to use the ideas from exponentials to make sure we can figure these out. We're rewriting it as an exponential, and we use learning target 3. So on the next one, we have 10 to the x power equals 0.01. Well, 0.01 is 1/100th. So how can I rewrite 1/100th as 10 to some power? Negative 10, negative 2. And so then x must be negative 2. So log base 10 of 0.01 is negative 2. We're using exponentials to evaluate. That way we can make those connections between logs and exponentials. It's not just some like magic number that just appeared. So same thing on the last one. Log base 7 of 1 over 343. So 7 to the x power goes 1 over 343. So 343 is 7 to the third. So 7 to the negative third. Are these ideas making sense? All right, then I want to do 2 more that are not on your note sheet really fast because of things that come up on your homework, and so I want you to see an example. Okay? So we're going to evaluate log base 81 of 3 and log base square root of 7 of 2,401. Again, we're going to set all these equal to x, if you will, so we can rewrite them. So this first one, if we rewrite it, we get 81 to the x power equals 3. Obviously, the bases don't match and we can't do what we just did. But in learning target 3, we had occasions where the bases didn't match either, right? And we could rewrite things to have the same base. So 81 is 3 to the what power? 3 to the 4th power, right? Yes. So 3 to the 4x equals 3, and that's 3 to the first, right? So really I have 4x equals 1, and so x is 1/4. We're using the same ideas as learning target 3. We have to rewrite those. So again, that just means that this log is equal to 1/4. All right, on this last one, I have the square root of 7 to the x power equals 2,401. I need to rewrite the square root of 7 because that's confusing. So how can I rewrite the square root of 7 with an exponent? 7 to the 1/2. So I have 1/2 x, right? Equals, and I need to write, obviously need to write 2,401 to 7 to some power, which I think is 7 to the 4th. So I have 1/2 x equals 4. So how do you solve that equation? Divide by half or multiply by 2, right? So x equals 8. So again, this logarithm is equal to 8. Just trying to make those connections. Any questions you have for me right now?